Okay, guys, here's part two. A few more problems that hopefully you know to help you do better on the final. So the thing I want to point out here, guys, is there will be one or two problems where you'll have to interpret or read a two-way table. And I just want to emphasize these values are the subtotals for the grade levels, and these two are the subtotals for who went to Disneyland, who went to Magic Mountain, right? But anyways, and here's, of course, our overall total there. That being said, sometimes that's not given. You'd have to figure that out, okay? But on the final, everything will be given like this problem. But anyways, let's get to the problem. The problem says, what is the probability that a student prefers Disneyland? Very straightforward probability. We know 24 like Disneyland. Some of them are 9th, 10th, 11th, 12th graders, but they're just saying out of all the students, see, they didn't specify what grade level. Hey, if I choose a student, what students prefer Disneyland? And you would say simply 24 out of 52. Voila. Now, normally they would have that reduced, which of course they did not do that in this problem. You normally would reduce it to, let's say, 12 out of 26 or 6 out of 13 would be a better answer. Okay, but hey, they didn't reduce it. More power to you, right? Anyway, so basic probability, guys, 24 out of 52 like Disneyland, right? Let's do the second question here. Now, this one says, what's the chance it was a 9th grader who likes Disneyland? Now, guys, the way I presented to you in class was like this. It's a conditional statement, you see? In other words, we know they like Disneyland. Remember, that's given, right? Given that, we know they like Disneyland. What's the chance now they are a 9th grader? See, by putting in that condition, in other words, I've just changed my world that I'm looking at, so to speak. And now I want to know the probability of a 9th grader. Well, hopefully you're still pretty good at this. But the idea is I now know they like Disneyland. So I don't care about Six Flags anymore. I know I'm not looking at 52 students anymore. I'm looking at 24 students because those are the only ones that like Disneyland, right? And that's what that right there means. We know they like Disneyland. So knowing that, how many are 9th graders? Do you agree there's 5 of them? So the answer is just simply 5 out of 24 are 9th graders that like Disneyland. And so therefore, that's why the probability or answer is B. All right, pause the video if you need to. 15, guys. This one don't worry about. Somehow it was done by mistake. See how it's a congruence thing? This is something you should have learned in IM1. But since it's on the video, why not do it anyways, okay? So anyways, they want us to use angle side angle. So if we look at our picture here, guys, note that we know, for example, that we have vertical angles right there, right? And we also know that we have these sides that are the same, i.e. the matching tick marks. So to get angle side angle, I have the angle, I have the side. What I need is the other angle on the other end of the side. So I would say B is congruent to D. Again, if you follow my black marker here, do I not now have a matching angle with a matching side between another matching angle, right? Again, I had a matching angle, the vertical angles, which is a matching side in between another matching angle. Once I know B is congruent to D. Okay? But if you forgot or did not learn that last year, don't sweat it. It's not on the final. We don't do triangle congruence on the final. Okay? Let's look at number 5. We know we're making 25 paper cones, but if you look carefully, all they care about is one paper cone. So who cares about there's 25 of them in this case? Okay? They told us the diameter is 4 inches, as shown there. So what's the first thing we're going to do is divide it by 2. The radius is 2 inches. That's what we need, right? The height is 7 as shown there. So how do we calculate this one, guys? We're simply going to take pi times the radius 2 squared. Pi r squared is the area of the circle. We're going to basically treat it like a cylinder, right? We're going to now times it by the height 7. So as you can see here, what I really have is pi r squared h, guys, if you want to know the formula so far. But remember, a cone is always 1/3 as big. So we're going to do 1/3 pi times 2 squared times 7. And so if you look at the calculator picture I just posted on the screen, guys, I did do 1/3 times pi times 2 squared times 7. Remember, a cone is 1/3 as big as its cylinder, right? That's where the 1/3 came from. And I got 29.3. What's the only one close to that? Is A, 29 inches cubed. Again, remember, volume is always cubic. It's 3-dimensional, right? Pause the video if you need to. Okay, finally, the last one, guys. This one I don't necessarily like because I'd rather you just do it on the calculator and get a more precise answer. But notice they gave us already approximations for sine, cosine, and tangent of 70. Now, I also made a mistake and did not copy or chopped off the actual question. I'm going to assume they want the length of the ladder, okay? If they want the length of the ladder, that means this right here is x, right? That right there is what I want. I want the hypotenuse, in other words. And notice the 4 is adjacent to the 70 here. So what uses adjacent hypotenuse, you should know, is cosine. I know the cosine of 70 degrees is got to be the adjacent over the hypotenuse. Notice how this is upside down. So again, you could put this over 1. And so we know that x times the cosine of 70 degrees equals 4. And we're going to end up dividing by cosine 70. Now, normally I would really want you to do that on the calculator. But we're going to use what's given here so we can find the right answer over here better. So if you do 4 divided by 0.3, because that's what the cosine of 70 is, you will get 13.3 feet. Okay? Now, guys, if they wanted how high the ladder reached, you would have used tangent and gotten instead the 10.8 feet. Okay, so I just want to clear up just in case I did the wrong problem there. But the important thing, guys, is you better know SOHCAHTOA. You better know your volumes. You better know similarity, even though that one was congruence. You better know some basic probabilities. Okay? I'll see you in class.